Hi, Dave here. Wouldn't a small, efficient 12-volt portable toaster oven be great, especially if you could build it yourself and the cost was super affordable? I've had a vision for this. It's freedom and independence. Cooking untethered, roast meat and vegetables, bake bread, all from one small 12-volt battery, anywhere, anytime. And it doesn't even take much power. This is a quick vlog update from my solar workshop. Not much of the work here can be shown on video. It just isn't possible right now. But one specific project nearing completion is right here in front of you. It's one of my small, affordable, and portable 12-volt toaster ovens, and they're just amazing. No, I'm not trying to sell them. This is a 100% DIY project for solar power enthusiasts who like to work with their own hands. Of course, I hope manufacturers will pay attention. We need an oven like this for the times ahead. Not everyone wants to build ovens themselves, but would still use one. Just a quick rundown on the specifications. It costs about $25 plus a few extra parts and materials. It takes several hours to build. This oven can run on anywhere from 12 volts up to 24 volts DC. It is extremely efficient, needing only about 144 watts to quickly reach baking temperatures of 350 degrees Fahrenheit and above. It is without a doubt one of the neatest inventions I've ever tested in my shop. I've built multiple of these ovens now in various forms, including 12 volts, 18 volts, 24 volts, and even PV to load. Yes, it can run straight off of solar panels with no battery whatsoever. Check the video description for the PV2L version. I want to show this project to as many DIY solar power enthusiasts as possible. This video is going to include a how to build guide as well as some footage of some of the tests that I conducted over the years with this oven running. If this video helps you out, please be sure to leave a thumbs up and let me know, as it really helps the channel. I think the world is going to need an oven like this for the hard times that are coming. It's useful for places that are truly off the grid, that are truly having hard times, and they can't get cooking fuel and so forth. Here is some brief background information on development work in my shop. I've spent hundreds of hours building prototypes of all kinds. Some are solar powered, some lithium, or both. I hope to show more of the many different inventions on camera in the future, but this oven was just too good to resist, so I had to find the time to present it. It was a very tedious process figuring out all the variables involved and solving the challenges. Some people have expressed doubts whether this oven can run off of such a small amount of power, but all doubts were proven wrong. This oven may look cute, but it packs a punch and it has a lot of neat features hidden inside. I did not want to start with a huge, expensive, thirsty oven taking 100 amps at 12 volts. It needed to be small, portable, lightweight, very efficient, and most of all, possible for solar DIYers to build themselves. And it needed to be cheap. Okay, the next part of this video is going to be the DIY build guide that's going to show me building the oven. I put a tremendous amount of work into this. It's over a year and a half of work. So if this video helps you out, please be sure to leave a like and also a comment and let me know. A portable 12-volt toaster oven for less than $50? Yes, it's possible, and I'm going to show you how to build it in this video. I've been working on this project since November of 2022, or possibly even before then, I can't remember. The footage I'm going to show next is me building one of these ovens from scratch. I have more than one. I have a lot of these ovens by now. It's just big enough to be useful, but small enough to be low power and portable. So where did I get this oven chassis to modify? The Dash Mini Toaster Oven has been around a long time. It's a very small 550 watt AC appliance intended for residential kitchens. It is cute, but it's nothing to laugh at. It's the cheap, affordable DIY mini 12-24 volt oven everyone wants but cannot buy. Well, not for $25. This video is for DIY solar power enthusiasts who like to work with their own hands, do research, and learn new skills. It's more than enough for you to start your own oven project. It's strange to me how ovens like this haven't been on the shelf for many years, but hopefully DIY enthusiasts can just start building their own and eventually the market will respond. Let's take a look at the source oven for this project. It runs on AC and frankly is still very attractive even if you needed to use an inverter with it. But I like using clean, low-voltage solar power and DC. When I can't find something on the store shelf, I build it myself. My workshop has a lot of prototypes. Necessity is the mother of invention. This oven uses small infrared quartz tube elements to cook the food, a timer mechanism, and an overheat protection device. Its construction is pretty average for these days. In order for this oven to operate off of 12 or 24 volts DC, we have to completely take it apart and modify it. So let's get started. I'm going to build another one of these ovens, but on camera so you can watch. It should be more than enough to get you started if you're interested in taking on a project like this. Please note this oven gets extremely hot and can burn your house down, so use the greatest abundance of care and caution. This thing is not a toy. Not all my work on this project was able to make it into the video at time of upload, unfortunately. As far as the timer switch, I have tested it with DC and it survived, but who knows how long. This oven project was streamlined down to the most basic parts. The first few prototype ovens were high-tech survival ready. No thermostat, not even a power switch, just clip right on the battery. This results in a very cheap and robust oven that can cook hundreds of meals for virtually no cost and zero fuel. The basic oven design has no moving parts and is very simple and reliable. Sure, one can use PWM, digital controls, timers, DC converters, and so forth to run the oven, but I had to start with the simplest route. DIYers can certainly customize their oven builds to be anything they want. Hopefully in the future I will be able to show the more advanced versions of my oven builds that use even less power. However, they take much more time and effort to build. As you might have guessed, I was not able to show all the detail that I wanted to in this video, and I had to go ahead and cut it short and post the upload, or it would never get done. I begin by unpacking and examining the oven. I remove several screws on the back and bottom of the oven. Inside, there is a fairly standard configuration of two quartz tube elements in series wired to a timer switch and a thermal protection device. The power cord is too thin for my application, so I won't be using it here. At the top, we can see the upper quartz tube element and its wire leading to the thermal protection device. There are two springs which hold the oven door closed when it is in the upper position. On the other side of the oven, the heating elements are simply wired in series with a single wire. The heating elements are not the same. The upper one has a higher voltage than the lower one. However, it really doesn't matter because neither of these heating elements is able to run off of 12 volts DC. This thermal overload protection device goes open circuit when the oven gets too hot. Whether or not you want to use this in your oven at 12 volts is a decision that's up to you. I continue the disassembly of the oven by removing all the wiring and wiring harnesses. It can be difficult to remove the wires, so sometimes I just cut them off. Here we can see that the AC power cord originally came in with a hot and a neutral. The hot connection, which I presume is a red wire, simply goes through the timer switch circuit and then returns back to feed the heating element. The other side of the return comes through the series elements that are in the top and bottom of the oven. In order to get this oven open, it is a very tedious process of removing all of the metal tabs which are bent or twisted in place. You must carefully adjust these tabs so that they pass through the slots, allowing you to disassemble the oven. Be careful with the tabs as they're easy to break. Once I have released the tabs on the back of the oven, the back cover plate can be removed. Here you can see the two quartz tube elements which are seated in between the two halves of the oven housing. Here you can see the thermal protection device is attached with two screws on the inner housing of the oven so that it can detect the temperature. And at the bottom is the lower quartz tube element. At the top there is an upper quartz tube element. Both of these tubes work together to cook the food using convection and also infrared. In order to access the bottom heating element, I must open the front enclosure of the oven where the timer switch is. At some point I'm able to separate the two halves of the oven housing enough that I can access the upper quartz tube element. In order to open the front enclosure of the oven where the timer switch is, I have to remove an additional screw below the oven door. Having done these steps, I can now remove the upper quartz tube element from its seat in the upper part of the oven housing. Here is the quartz tube element removed. It is built pretty much the same as any other quartz tube element I've ever seen. In the past, I have modified many of these quartz tubes to heat my home in the winter using solar power. If you are interested, a video link is in the description. With the oven nearly completely disassembled, I can now finally remove the lower quartz tube element. Here's a quick look at how some of these quartz tube elements are constructed. This information is also covered extensively in some of my other videos on the channel. Both of these quartz tube elements are of a different rating, but it doesn't matter because we're going to have to modify them anyway. Here's a look at the oven door removed and still attached to the front part of the enclosure. This is the rear of the timer switch showing its bell. I personally don't use it and don't need it in my design. The way the oven was designed, this switch was only going to handle about 5 amps. In my design, it's going to have to handle a lot more, so I don't use it. Perhaps in the future I'll have time to run 12 volts through it and see what happens. One of the most challenging parts of this build is modifying the heating elements to be properly balanced and running off of 12 volts DC. What I need to achieve is about 11 amps of current through both of these heating elements. I want my bottom element to dissipate most of the power and the top one a bit less. I will start by modifying the lower quartz tube element, which in my design will dissipate most of the power. I will remove the ceramic shoulder cap from both ends of the heating tube element. For the bottom element, I will not be using the heating element wire, but I will be winding my own element. Now, generally speaking, when modifying these quartz tube elements, you have the option of stretching the existing heating element wire, which I will not be doing for the bottom element, or winding your own heating element wire using your own resistance wire, which I will be doing in this case. To wind the bottom heating element, I'm going to use generic nichrome wire. If you're interested in learning more about winding heating elements, making the calculations and so forth, please check the video links in the description. You can use Ohm's formula to calculate the resistance of the heating element. My oven needs to dissipate at least 140 watts at 12 volts. Obviously, it means my heating element needs to be right around 1 or 2 ohms of resistance, but keep in mind this is a moving target and changes while the oven is in operation. Therefore, making your own heating elements can be a very tricky and frustrating exercise. Here is the heating element I wound for the bottom quartz tube. As you can see, it's fairly thick wire. For the upper heating element, I'm simply going to stretch it and remove some of the existing OEM heating wire so that it works better with 12 volts. I'm not going to use my own heating wire in that case. I use the same knowledge to modify quartz tube infrared space heaters. There's more information linked in the description. One of the simplest ways to make a heating element in your workshop with basic hand tools is to take a screwdriver and wrap the heating element wire around it in the shape of a coil. I have not been able to spend a lot of time refining the process due to the circumstances here, but I will comment that a power drill may help you in winding heating elements in some cases. So I just wrapped the heating element wire around a screwdriver. That's about as sophisticated as it's going to be until things change around here, but it does the job. So there's a look at my heating element. It's not perfect, but like I said, it does the job. It's a good idea to make sure the individual coils are not touching one another because that would short out the heating element and it might start acting differently under certain conditions. The original terminals are not really convenient to use with my new heating element. I'm going to improvise and use spade terminal connections to re-terminate the heating element. This is not necessarily safe or recommended, but in a pinch, it does work. Pretty much everything I do here is rushed and improvised, so here I'm just modifying the spade terminals and I'm going to use them for my heating element. It's not ideal, but it'll do the job. I will attach the heating element wire to the spade terminal and make sure and give it a really secure crimp. It really isn't safe to use insecure connections on the end of a heating element. What I'm showing you here is just me using what I have access to at the moment to create the end terminals. At the factory, they're usually welded in some way and crimped, and that's a very secure connection. If you're going to use the improvised method to terminate these heating elements like I'm showing you here, make sure that the nichrome wire is very clean and the terminals also before crimping the connections. Okay, I've crimped the spade terminal onto the end of the heating element. If this heating element doesn't look quite perfect to you or meet your standards, please keep in mind the entire project was conducted under the greatest of duress and the most challenging of circumstances, so please keep that in mind. Now, one of the tasks is trying to get the heating element back into the tube. This can be quite frustrating and it may take you several tries to get it right. The ceramic shoulder cap now has to be fitted back over the spade terminals to securely hold the tube in place. And of course the spade terminal needs to be secured in some way so that it doesn't pull back inside the tube. Okay, so the upper heating element, I'm going to be stretching that one rather than replacing the resistance wire. Again, there's already quite a lot of information on my channel about doing that. This upper heating element will be placed in parallel with the existing heating element, and all told, I need them to dissipate about 144 watts or something like that. As you can see, I've stretched and shortened the heating element significantly to make it work with my new design. Having modified the upper heating element, I'm just going to reassemble it the same as I did the lower heating element using my own improvised crimp terminal. And there's the upper heating element that has been stretched and modified and ready to go. Now this part of the task is rather difficult, but just be glad you're not in the state I'm in. It'd be 100,000 times worse. This oven is very fiddly to put back together and it has a lot of sharp edges. When reinstalling the quartz tubes, take care not to damage them and make sure there's no binding or pressure on the tubes because it's possible they could crack or be destroyed later when the oven is in operation. Let's talk more about the quartz tubes while I'm reassembling the oven. When all these heating elements are connected, they will be right around 1 or 2 ohms. Of course that changes as they heat up. I'm only running on 12 to 13 volts, so I don't have a lot to work with. Obviously you need a fairly low resistance element in order to get enough current to flow. Again, I have all kinds of information linked in the description if you want to learn about this subject in detail. You might be shocked to learn this oven only needs about 130 to 140 watts to reach baking temperatures of over 350 degrees Fahrenheit. Later on in the video, you're going to find out why that is. In short, to get that kind of power, I need about 11 amps of current flowing into this oven. And so that's how you do your mathematics and your calculations to determine what resistance or what kind of heating elements you're going to use. Now there's a lot of different ways to wire these heating elements up and how to configure them. You can use your own heating wire, you can reuse heating wire, and that's all up to you. Some of this is really going to take some hands-on DIY, some research, some patience, and some understanding, and eventually you'll get there. If you feel this project is too much to take on, you can always team up with someone who has more experience and more knowledge and learn something along the way. That's what I recommend. So I'm just continuing on with reassembly and installing the screws. And I install the springs with the hooks facing out. You'll soon find out why that is. Took me a really long time, but I mostly got the oven reassembled and now it's time to do the wiring. As you might have guessed, this oven gets extremely hot, so soldering the connections could be problematic. So for the heating elements, I will be using crimped-on spade terminal connections. This is non-aluminum wire. It's high strand count tin copper wire with a silicone jacket. When wire is silver, that doesn't necessarily mean that it is aluminum. Because the oven gets incredibly hot inside, it's important to use good quality wire. Don't use PVC jacketed wire, use something really durable that can handle high temperatures. The oven came with these fiberglass high temperature insulation sleeves, so I'm going to reuse them wherever I can. I am careful to protect the ends of the crimp terminals so that they don't make contact with something metal and short out. Shrink tubing would be a poor choice in this case, that's why I'm using the fiberglass sheathing. And now for the secret of this extremely efficient mini oven, ceramic fiber kiln insulation. I use this material all the time in all kinds of projects, and it's incredibly useful and valuable. Because of the insulation, this oven is able to run off of an incredibly small amount of electrical power, making it truly versatile and unique in its class. All of my ovens use this ceramic material in their design, as well as other thermal management techniques. Some people say these ovens can't work with such a small amount of power, but I've been building them for a long time and I know they work just fine. I hope these projects can make the world a better place. If these prototypes didn't work, I wouldn't spend so much time building them. Not to mention that all this effort has come at great personal cost. This material is rather dusty, so you should probably wear a dust mask to prevent from inhaling the particles. I carefully fit the insulation inside the oven, making sure all the connections, all the terminals, and all the wiring are outside the insulation. You should never trap the connections or wires in between the insulation and the metal part of the inner oven housing. I'm working on a better insulation solution for this oven, but right now this ceramic fiber kiln insulation is the easiest and the quickest way to get the oven to the point where it's efficient enough for daily use. Using the high-quality silicone jacketed wire, I created a wiring harness which will connect both heating elements in parallel to the 12-volt battery feed. A fuse, circuit breaker, or other protective device needs to be used with this oven to help guard against short circuits and overload. Take care when fitting the springs in the wires that the oven door mechanism does not interfere with the wires or shred them, causing them to make contact with the case, which is metal and will conduct. Here I'm just running the negative side of the feed from the heating elements through the oven enclosure and out the other side. I will not use the existing AC power cord because it is thin and I'm only running at about 12 volts. I chose not to use this thermal protection device in my design. I may experiment with it more later if I'm able. Nor will I be using the timer, which has 2 red wires to interrupt the hot side of the circuit. I don't really need it in my design. Maybe I'll experiment with it later. I am also continuing to install the ceramic fiber kiln insulation on the other side of the oven. Now I'm installing the positive side of the wiring harness to the other 2 sides of the heating elements, which will be placed in parallel. These are fairly heavy wires and should be able to handle around 11 amps at 13 volts with no problem. Be advised that you need to install a proper cord clamp or a rubber grommet to protect the positive and negative wires where they enter the oven chassis, otherwise there's a very high risk of short circuit if the wires are cut through. The next chore is to get the outer oven enclosure fitted back on with everything inside. When closing the oven back up, there's a risk that you could pinch a wire, and it's very easy to cut a wire and you would have a 12-volt high current short circuit. So again, make sure you use a fuse, and it might take several tries to get everything back together again without pinching or cutting a wire. Then I reattach the 4 screws to the bottom of the oven to hold it together. It's simple, cheap, lightweight, efficient, and works so good. Cooks endless meals with very little power and without burning fuel. Perhaps it's just too good, too simple, and too cheap for companies to be interested in making a more refined, mass-produced version. We'll see. It has no Bluetooth, no app, no Wi-Fi, no Internet of Things, and it doesn't take a degree in engineering to figure it out. I hope manufacturers will take notice of this simple oven. There are so many opportunities for new products and innovations. I've had this oven a long time and wasn't able to do much about it. Finally, I can show it to you. These should have been on the store shelf years ago. Please check out the video description and my solar cooking and prototype playlist for more information and content. If this kind of project interests you, please stay tuned and also check out my other content and project center uploads. I am hoping I will be able to get some more of my work on camera as soon as possible. Thanks for watching, and I'll see you next time.